Welcome back, folks. Today we're going to wrap up Chapter 7 with Lesson 7.5, Proportions in Triangles. Basically, today I've got two theorems we're going to show you how to use. Our objective is to use the side splitter theorem and the triangle angle bisector theorem. Here we go. Alright, the side splitter theorem says that if a line is parallel to one side of a triangle and intercepts the other two sides, then it divides those sides proportionally. Okay, so in other words, if I have a segment running through a triangle parallel to one of the sides of the triangle, it's going to split these sides proportionally, as in QR over XR, that ratio, that fraction, will be equal to QS over SY. Alright, now why does that work? Well, when I make a line through a triangle parallel to another side, essentially I'm making two different triangles, a bigger one and smaller one. And as far as how these two triangles relate to each other, they're going to share an angle, so that's one congruent angle. And then these parallel lines are going to make the other two angles congruent as well. Okay, so by our angle-angle similarity postulate from the last lesson, I know that these two triangles are similar. Okay, if they're similar, they'll have proportional sides, which means when I go and split the side up, I'll get proportionality there as well. Let's go ahead and show you how to use that side splitter theorem. So problem 1, part A, what's the value of x in the diagram at the right? Okay, I have a triangle with a segment running through it parallel to the bottom of the triangle, so my side splitter theorem applies. That means the left and right sides will be split proportionally. So if I want to solve for x, I can set up the proportion. I can just say 12 over x plus 1 is equal to 9 over x. Okay, notice the way my proportion looks. It basically looks the same way it does in my picture. Okay, I can essentially just set that proportion up with the numbers as they are in the picture. There's other ways you can set it up, but I'd recommend make it look like the picture and you know you're going to get it right. Okay, we got an uglier proportion here, but we've done these before. Let's cross multiply. Okay, 12 times x will just be 12x. That's one of my cross products. And then for the other one, I need to take 9 times x plus 1. I'm going to write that as 9 parenthesis x plus 1. And I've got the parenthesis there because I need to make sure to distribute the 9 to the x and the 1 here. So rewriting this, we have 12x is equal to 9x plus 9. Alright, so solving proportions, cross multiply, we did that. And then the uglier ones will say cross multiply and solve whatever we're left with. To do that, I'm going to subtract 9x on both sides to get the x by itself. Cancel that out. Leave me with 3x is equal to 9. And then we can divide both sides by 3. And we end up with x is equal to just the 3. Alright, so there's an example of using our side splitter theorem. Okay, problem 1 part B is the same idea. Why don't you take a minute, pause the video, give that one a shot, work through it, and then hit play to check your answer and make sure you did things correctly. Alright, so here's the answer for part B. Why don't you take a minute, pause the video, make sure you got the same thing, and if you missed it, see if you can find where your mistake was and how to fix that. Now, next thing we're going to talk about is an extension or a corollary to that side splitter theorem. Basically, the way it's going to work is instead of just having a single parallel line through a triangle, I can have multiple, and my sides are still going to get split up proportionally. That's our corollary here. And with the corollary, we can think of this triangle or these lines extending to form a triangle. And we can actually skip the triangle completely and just look at partial triangles here with parallel lines and traversals. Okay, corollary says if three parallel lines intersect two traversals, then the segments intercepted on the transversals are proportional. Okay, so in other words, we get the same result. We get AB over BC is equal to WX over XY. Now, where this theorem is going to show up in the real world a lot is dealing with plots of land. Okay, if you think about your yard, chances are the sides of it are going to be parallel to the neighbor's yard. Okay, but the front and back sides might have some different dimensions. Okay, problem 2 says two plots of land are shown below. What's the unknown length, x? Okay, so what is this distance along the backyard, we could say? Again, since my vertical lines are parallel, I know the horizontal transversals are going to be split proportionally. So I can just say that x over 70 is equal to 62 over 56. Okay, bigger numbers here, but simple proportion. Okay, just single x. Cross multiply. X times 56 will give us a 56x is equal to 70 times 62 is 4,340. At least that's what my calculator tells me. Divide both sides by 56. And that's going to give me my x is equal to 77.5. Okay, so we'll say 77.5 feet, okay, for the back side of that plot of land. All right, other theorem we're going to take a look at deals with something completely different. All right, but the theorem gives us the same result. Okay, so problems are going to work out the same way. Next theorem we have is the triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Okay, so if I have a larger triangle, ABC, and I draw an angle bisector, a ray that divides that angle into two congruent parts, this theorem is telling me that the opposite sides will be split proportionally to the other two sides. Okay, so in other words, we get the same result. We could say CA over CD is equal to BA over BD. Let's take a look at a problem using that triangle angle bisector theorem. 3a says, what's the value of x in the diagram at the right? Okay, so again, triangle angle bisector theorem applies because I have my larger triangle with one angle bisected, okay, with this angle P split into two congruent parts. Okay, that means that the opposite side will be split proportionally to the other two sides of the triangle. So I can say that 10 over 12 is equal to 18 over x. Okay, cross multiply, we get a 10x is equal to 12 times 18 is 216. Divide both sides by 10, and we end up with x is equal to 21.6. All right, for that missing side of the triangle. All right, that's part A. There's a part B as well. Why don't you take a minute, pause the video, see if you can set up that proportion and solve it, and then hit play to check your answer before you wrap things up. All right, there you go. There's your answer for part B. Make sure you get the same thing. If not, okay, match your work up to this work here. And if you're good, you're ready to start getting some practice in, so do the homework, and if you need help, we'll be here to help you out.